Welcome to Daedalus Debugger, a podcast series conceived by Lucianoambrosini and co-created with me, Aive. Today we will discuss digital twins, applications and trends in architecture and construction.
Welcome back to the Deep Dive.
Thanks for having me.
Today we're talking about digital twins.
Yeah.
Specifically, digital twins in the built environment.
Right.
So, whether you're an architect or an engineer or a designer, this is a deep dive that should be really fascinating for you.
Really interesting stuff.
So we have a lot of different research to go over today.
Yeah, we've got research papers, we've got white papers.
Real world case studies, the whole 9 yards.
Yeah, absolutely.
So first things first.
Okay.
What is a digital twin?
Well, that's a great question.
Because I've heard it described in a lot of different ways.
Yeah, it's kind of a tough thing to define.
Virtual replica,
Yep.
simulation.
Yeah.
Where do we even begin with that?
And that's actually one of the first things that I noticed when I was reading through the research,
Right.
is that there's no one universally accepted definition of a digital twin. It's still kind of like evolving.
So how do we make sense of it then?
Well, one thing that researchers have put forward is this idea that it's made up of 5 key components.
5 key components, okay.
Like ingredients in a recipe.
Got it.
So the first one obviously is data.
Okay, data, yeah.
That's the DNA of your digital twin.
So what kind of data are we talking about here?
So it could be like blueprints,
Okay.
3D scans, real-time readings from sensors,
Oh, wow.
historical performance data.
So it's not just about what the building looks like. It's
Okay.
also about how it functions.
Yeah, exactly.
All the data that's coming from it.
Yeah.
Okay, so what's the next ingredient?
So the next one is modeling.
Modeling it.
So this is where you take all that data
Right.
and you turn it into something meaningful.
Okay.
So that might be like creating a simulation model, maybe using some AI or a machine learning algorithm.
So that's kind of where the intelligence comes in.
Yeah.
It's not just a static copy. You
Oh,
can
wow.
actually, make predictions and things like that.
That's exactly.
Okay, what else?
The next one is infrastructure.
Infrastructure. So like the physical infrastructure.
Well, not exactly.
Okay.
This is more like the digital infrastructure.
Got it.
So we're talking about cloud platforms, high performance computing systems,
Yeah.
the Internet of Things.
Right.
All of that is the foundation that allows the digital twin to exist and function.
It's wild to think about how much technology goes into this.
Yeah.
It's like you're building a building in the cloud.
It really is.
Okay, so we've got the data, we've got the model, we've got the infrastructure. What's next?
So next you need an interface,
An interface.
like a bridge between the digital and the human world.
Got it.
So that might include things like APIs, visualization tools, dashboards.
Right. So we can actually understand what's going on.
Exactly. Yeah.
Make sense of all that data. So what's the final ingredient in this recipe?
So the final one is what they call system aspects.
System aspects.
And this is where it gets really interesting.
Okay.
So system aspects include things like data validation,
Okay.
security protocols,
Right. Yeah.
ethical considerations.
So making sure that we're using this technology responsibly.
Exactly.
Okay. That makes sense. But, I think we should address the elephant in the room here.
Okay.
Some people might be listening to this thinking, wait a minute,
Yeah,
isn't this just a fancy 3D model?
Right.
I've been using 3D models for years.
that's a great point.
So what's the difference?
Well, the key difference is that a 3D model is static.
Okay.
It's like a snapshot in time,
Right.
whereas a digital twin is dynamic.
Dynamic. Okay.
It's constantly evolving.
So it's like the difference between, looking at a blueprint
Yeah.
and watching a live security camera.
Exactly. That's a great analogy.
One is just a representation.
Right.
The other one is actually showing you what's happening right now
Exactly.
in real time.
And that real-time connection opens up so many possibilities.
Yeah, because you can see how things are actually functioning. You
Yeah.
can see how they're performing.
Exactly.
And you can start to make predictions about what might happen in the future.
Absolutely.
Okay.
So, for example,
Yeah.
imagine being able to simulate the impact of design changes on a building's energy efficiency
Oh, wow.
before you even break ground,
That's incredible.
or predict when maintenance is needed before a system fails.
to avoid those really costly downtime.
Exactly.
Yeah, potential safety issues too.
Absolutely.
Wow.
So you can move from just reacting to problems to proactively optimizing performance.
I love that.
Mm-hmm.
It's about making smarter decisions.
Yeah.
throughout the entire life cycle of the building, or even a city.
You're absolutely right.
Now, speaking of which,
Okay.
researchers have identified two main types of digital twins.
That's right.
So there's high performance, real time. We'll call that HPRT.
Okay.
And then there's long-term decision support, LTDs.
Yeah.
So what's the difference?
So HPRT digital twins are all about speed.
Okay, speed.
They need massive computational power to process data in real time and give you immediate feedback.
So that's more for things like maybe self-driving cars.
Yeah, great example.
Or like high-frequency trading.
Exactly.
Where those split-second decisions are super important.
Right.
What about LTDs?
So LTDS is more about strategy and planning.
Okay.
Using data to make informed decisions over longer periods.
So thinking about the big picture.
Exactly.
Okay, so which one is more relevant to the built environment?
Well, that's where it gets interesting.
Okay.
Research suggests that when it comes to building, architecture, urban scale, the focus is currently leaning more towards LTDS.
Oh, really?
Yeah.
So instead of buildings that can react in real time,
Right.
it's more about cities that can predict traffic patterns years in advance.
Exactly.
So why is that?
Well, I mean, think about it. The built environment, it evolves slowly.
Right.
Buildings last for decades,
Yeah.
cities even longer.
Yeah.
So the decisions we make today have these really lasting impacts.
Right.
So we need tools that help us understand those long-term consequences.
So it's less about reacting and more about making smart choices for the future.
Exactly.
So LTDS digital twins,
Yeah.
they can help us model different scenarios, predict outcomes,
Right.
optimize systems for efficiency, for resilience.
Exactly.
That's a powerful tool.
It is.
For architects, for engineers, for designers.
It really is.
Now, we've covered a lot of ground already,
Yeah, we have.
but we're just getting started.
Yeah.
So up next, we'll be looking at some real-world examples of how digital twins are being used in the built environment,
Can't wait.
from individual buildings to entire cityscapes.
Absolutely.
So stay tuned.
It's only going to get more interesting from here.
We'll be right back.
Okay.
Okay, so we've kind of laid the groundwork here.
Yeah.
We know what digital twins are. They're not just fancy 3D models,
No, definitely not.
and that long-term decision support is where they really shine.
Absolutely.
But let's get down to, the real world stuff.
Yeah, let's see them in action.
What are some examples of how digital twins are actually being used out there today in the built environment?
Well, there are some really cool examples.
Right.
And the applications are growing so fast.
I bet.
One that comes to mind is Singapore's Virtual Singapore project.
Oh, yeah, I've heard that.
They've created this city-scale digital twin,
Wow.
and they're using it for all kinds of things.
Like what?
Urban planning,
Okay.
disaster management, optimizing infrastructure.
So like making the city run more efficiently.
Exactly.
What else?
They're even testing out new policies and initiatives virtually before implementing them in the real world.
That's amazing.
It's like a giant sandbox for city planners.
Wow, so a whole city.
Yeah.
What about like at the building level?
Oh, there are tons of examples there too.
Okay.
We're seeing digital twins used to optimize energy use,
Okay.
predict and prevent maintenance issues,
Yeah.
and even improve the safety and efficiency of construction projects.
That's cool.
There's this one case study I read about.
Okay.
A construction firm in Europe was using a digital twin to simulate the assembly of this complex facade system.
Oh, wow.
And they were able to identify clashes and optimize the sequence of operations before they even started building.
That's brilliant.
Yeah, it saved them so much time and money.
And probably a lot of headaches too.
Oh, for sure.
So it's like a dress rehearsal for the construction project.
Exactly.
You can work out all the kinks beforehand.
And speaking of rehearsals,
Yeah.
I read that digital twins are being used to train robots for construction work.
Oh, really?
Yeah, you can simulate different scenarios in the digital twin, test out different approaches, and make sure those robots are ready to go when they hit the real-world construction site.
That's wild.
Yeah, it's really changing the game for productivity and safety.
It's like those lines between the digital and physical worlds are getting blurrier all the time.
They really are.
It's not just new construction either, right?
Right.
I heard they're using digital twins to help preserve historic buildings.
Oh, yeah, that's a really exciting application.
How so?
Well, they use things like laser scanning and BIM to create these really detailed digital replicas of historic buildings.
Okay.
And those replicas can help with preservation and restoration efforts.
So it's like having a digital archive of the building's history.
Exactly.
So you can see how it's changed over time and make more informed decisions about how to protect it.
Yeah, and restore it for future generations.
That's awesome.
It's a really powerful tool for preservationists.
Okay, so we're seeing applications across the entire life cycle of the built environment.
We really are.
From planning and design to construction, operation, maintenance, even preservation.
It's a versatile technology.
But let's be real, every new technology comes with challenges.
True.
So what are some of the hurdles that need to be overcome before digital twins become, like the norm in the built environment?
Well, one of the biggest challenges, and this came up again and again in the research, is data integration.
Data integration, right?
Buildings and cities generate tons of data.
From everywhere.
Exactly.
Sensors, building management systems, weather data, traffic data, you name it.
And getting all of that data to work together,
right?
That's a huge challenge.
Yeah, it's like having a bunch of different puzzle pieces that don't quite fit together.
Yeah, you need some kind of universal adapter.
Right, exactly.
And then there's the issue of interoperability.
Interoperability, okay.
Different software platforms and data systems need to be able to talk to each other for the digital twin to work properly.
Right, otherwise it's like, what's the point?
Exactly.
And everyone is using their own system.
Yeah, you just end up with these silos of information.
Which defeats the whole purpose of having this integrated view of the built environment.
Right. We need open standards and a much more collaborative approach to data sharing.
That makes sense.
Otherwise, we're not going to unlock the true potential of digital twins.
So it's not just about the tech itself.
No.
It's about creating the right environment for it to thrive.
Exactly. It's about building an ecosystem where information can flow freely.
I like that.
Systems can talk to each other.
Okay, so data integration, interoperability. What else?
Another big one is the need for skilled professionals.
Right, people who can actually build and manage these systems.
Exactly.
So we're talking architects, engineers, designers, data scientists, software developers.
We need all of them.
And they need to understand both the built environment and the digital world.
It's a whole new skill set.
Yeah, it's exciting though, right?
It is.
It's like we're creating this new breed of Renaissance thinkers.
I love that analogy.
Fluent in both design and data.
Yeah, that's the future.
Okay, so we've got the skills gap. What else?
Well, and then there's the cost.
Right. Money always comes into play.
It does.
Implementing this kind of technology, especially at a large scale,
Yeah.
it's got to be expensive.
It can be a significant investment up front.
But I guess the research suggests that the long-term benefits outweigh the costs.
That's what they're finding.
Reduced operating costs, better efficiency, better decisions overall.
Exactly. It's an investment that pays off over time.
Okay, so let's switch gears a little bit.
Okay.
And talk about what's on the horizon.
The future of digital twins.
Yeah, what are some of the trends, the innovations that are shaping the future of this technology?
Well, one area that I'm really excited about is intelligent system control.
Intelligent system control.
So basically, we're talking about using AI and algorithms to automate the management of buildings and infrastructure.
Oh, wow. So
imagine buildings that can adjust their own energy consumption based on occupancy or the weather.
Like a smart thermostat, but for the whole building.
Yeah, exactly.
Or a traffic management system that optimizes flow in real time.
Yeah, so you could reduce congestion.
Yeah. No more traffic jams.
Wow. We can dream.
But it's pretty amazing to think about, right?
It is. It's like something out of a sci-fi movie.
Buildings that can think for themselves.
Cities that can adapt and respond to changing conditions.
Wild.
And then there's model automation.
Model automation. What's that?
So instead of painstakingly building a digital twin brick by brick, we're teaching computers to do it for us using AI and machine learning.
So it's faster, more efficient.
Exactly.
Less manual labor.
And it frees up human experts to focus on the things that computers can't do.
Like the creative stuff.
Exactly.
The problem solving, the big picture thinking.
Yeah, the stuff that really makes a difference.
This is incredible stuff.
It is.
We've covered so much ground already.
I know, it's a lot to take in.
But before we wrap up, I want to go back to something you said earlier, that systems perspective.
Right.
And the importance of collaboration.
Yeah, that's crucial.
Can you talk about that a little bit more?
Sure.
What do you mean by a systems perspective?
Well, digital twin technology really helps us see how everything is interconnected.
Okay.
We can move beyond thinking about buildings and infrastructure as these isolated things.
Right.
And start to see them as part of a larger system.
A system with lots of moving parts.
Exactly. A complex web of interactions and dependencies.
So instead of just optimizing a single building,
right,
you're thinking about how that building impacts the whole neighborhood.
Yeah, and the city as a whole.
The energy grid, the transportation network, even the social fabric of the community.
It's all connected.
And that's where collaboration comes in.
Absolutely.
We need to break down those silos.
Yeah, between architects and engineers, city planners, policymakers, everyone.
Everyone needs to be at the table,
right,
sharing data, working together.
To create a more holistic vision of the built environment.
That makes so much sense.
And it's not just about sharing data.
What else?
It's about sharing knowledge and expertise.
So architects can learn from engineers.
And vice versa.
City planners can learn from data scientists.
We can all benefit from each other's experience.
It's like building this digital city hall.
I like that.
Where everyone has a voice and can contribute to a better future.
That's the goal.
But let's be realistic.
Okay.
We're still early in the game here.
We are.
What are some of the challenges in fostering that kind of collaboration?
Well, overcoming those traditional barriers between disciplines is a big one.
Right.
Architects and engineers and data scientists, they all speak different languages. We need to find a way to bridge those gaps.
Like a universal translator for the built environment?
Exactly.
What else?
Trust is a big one.
Sharing data can be scary.
It can be, especially when it's sensitive information about people.
So we need clear guidelines for privacy and security.
Absolutely. People need to feel comfortable sharing their data.
It's about building trust and transparency into the system from day one.
Right, and recognizing that collaboration takes time and effort.
It's not going to happen overnight.
No, it takes work.
People have to be willing to put in the effort.
But the rewards are worth it.
Because if we can get it right,
yeah,
we can create digital twins that truly reflect the complexity of our world.
And that's a really exciting prospect.
Absolutely.
I think that's what makes this field so fascinating.
Okay, so we've talked about the definition of digital twins. We've looked at real-world examples, and we've discussed some of the challenges ahead.
It's been a great conversation.
Before we wrap up this part of our deep dive, is there anything else you want our listeners to keep in mind?
Well, I think the key takeaway here is that we're just scratching the surface of what's possible with digital twins.
We really are.
This technology has the potential to revolutionize the way we design, build, and manage our built environment.
It's a game changer.
But it's important to remember that digital twins are not a magic bullet.
Right. They're not going to solve all our problems overnight.
They're powerful tools.
But we have to use them wisely.
Exactly.
We have to think about the ethical implications.
We have to make sure that everyone benefits from this technology.
That it doesn't create new problems or make existing inequalities worse.
Right. It's about responsible innovation.
That's a good way to put it.
And it's important to remember that this is a constantly evolving field.
There's so much more to discover.
Yeah, there's a lot of research and development happening.
It's going to be exciting to see what the future holds.
It really is.
It really is amazing to think about all the possibilities. You know, before we wrap up, I wanted to circle back to something we were discussing earlier.
Oh, yeah.
Those two main types of digital twins, the HPRT and the LTDs.
Right, yeah.
So the long-term decision support ones, those seem to be like the dominant type in the built environment, when you say.
Yeah, I think so, for now at least.
And I think you mentioned that the research suggests that building and architecture, even like urban scale digital twins, are all leaning more towards those LTDS applications.
Yeah, definitely.
Why do you think that is?
Well, I think part of it is because, like we said, buildings and cities, they just evolve so slowly.
Right.
But I think there's more to it than that.
Okay.
You know, we're facing all these big challenges today, like climate change, population growth, resource scarcity, aging infrastructure.
That's a big one.
Yeah, and these are really complex issues. You can't just, fix them overnight.
It takes long-term thinking.
Exactly. Strategic planning, looking ahead.
And those LTDS digital twins can really help with that.
Exactly. They let us model different scenarios.
Right.
Like play out these what-if games.
Oh, interesting.
Yeah, and see how our decisions might play out over decades.
Wow. So instead of just reacting to problems, we can try to anticipate future challenges.
Exactly.
And come up with solutions that are going to be more resilient.
And sustainable.
Yes.
Over the long term.
That's incredible.
Yeah.
It's like having a time machine for the built environment.
It really is.
Like fast forward 50 years and see what happens.
See how your building is holding up.
Yeah.
Or how traffic is flowing in the city.
So cool.
It lets you make decisions based on data and evidence. Not just, your gut feeling.
So LTDS digital twins.
Yeah.
They're not just about making buildings and cities smarter.
No.
They're about making them more resilient, more adaptable,
right,
and ultimately more sustainable for the future.
Exactly.
That's what I find so exciting about this technology.
Yeah, me too.
It's not just about making things a little bit better.
Right.
It's about fundamentally changing how we think about the world around us.
Yeah, it's a whole new way of thinking.
Well, this has been an incredible deep dive into the world of digital twins.
It really has.
Thanks so much for joining us today and sharing your insights.
It's been my pleasure.
I feel like we've only just scratched the surface, but hopefully our listeners have a much better understanding of what digital twins are and how they can change the built environment.
I hope so, yeah.
And to our listeners out there, keep exploring this stuff.
Definitely.
The future of our cities and buildings, it's being shaped right now.
It is.
And if you understand and embrace the power of digital twins,
you'll be at the forefront of this amazing revolution.
It's exciting to think about.
It really is.
Well, that wraps up this episode of The Deep Dive.
Great talking to you.
Thanks again for joining us. And until next time, keep exploring, keep innovating, and keep pushing the boundaries of what's possible.
Thanks for listening. See you on the next episode of Daedalus Debugger, the architect in the digital maze. Bye!